This is the first of a short sequence of slides on the general linear model, or rather testing within the general linear model. We're going to look at how to test linear hypotheses in multiple regression and perfectly general hypotheses. So to start with the most basic version, if we have a linear model which has just one x variable, one independent variable, we would typically write the mean or expected value of our response, a y, to be some linear function of the axis. And the first thing we usually do is we rewrite this as a matrix form. So we set up the x matrix consisting of all ones, and then the axis to xn, and set for y also in matrix form y1 to yn, and then we say these y's are equal to these times an alpha and a beta plus some residual of e1 to en. And or in matrix format, in other words, we're writing y is x beta plus an e. And the question then is, can we drop this x? That's the obvious hypothesis test. That's the same thing as asking whether the null hypothesis that beta is 0 is true. And it's also the same hypothesis as asking whether we can simplify x from being a two-column matrix into being a one-column matrix. So can we actually write y equal to z gamma times a different e vector? Right? Are these equivalent? So in other words, can we do this? That's the question. And the answer will be, we can do this if there's not too much difference in the predicted outcomes. There are many other instances where we want to do this, and let me start with another example also. Here's what we call the one-way analysis of variance, one-way ANOVA, or analysis of variance in the one-way layout, or a single factor analysis of variance, all the same. Here what we have is we have a y, and this has an overall mean plus some variability depending on the treatment that you've given, or the fertilizer you've used, or the gender of the person you're asking, and so forth. So there is some factor here which is discrete, can take on one or more levels, and that has an effect on the outcome. And then we have some measurement variation, and we have a number of these groups, two or more, and then we have measurements within each group. And we're just going to assume that there's a fixed number of measurements in every group for now. We can write this up by ordering these y's. So y11, that's the first measurement of group 1, second measurement of group 1, and so forth, up to the ith measurement, jth measurement of group 1. And then we do this for the second group, third group, and so forth, and we finally end on the last group. We do yij here. And then we need to sort all of these, we need to arrange all of these coefficients together, all these unknown parameters, if you like, alpha 1 to alpha I, and then we need to say which multiplier applies to each one. For y11, we want the mu, of course. We then want alpha 1, and we don't want any of the other alphas. For mu12, exactly the same model. The only difference between these two is the error term. So here we need a plus, epsilon 11 or e11, depending on the mood you're in, 1, 2, and so forth. And this goes only one down to ij, exactly as the other. And then this keeps on going down to the jth one, 1, 1, 0. And then for the third one, what we have is we have a 1, and then alpha 1 doesn't appear, but alpha 2 appears, and so forth. This keeps on going all the way down to the last block, where we have these zeros, and then we have ones only in the last column. 0, 0, and so forth. Right? So this is the one-way layer. Here, we're interested in testing whether all these alphas are 0, where we can drop all of them. So the same for the X matrix. We want to know whether we can drop all of these columns and be left with only a single one. So that would be a typical test in the one-way layer. So this general version, what's actually going on is we have an X, and we want to know whether we can reduce this to a Z. And if we think of the X as spanning a space, then we're trying to reduce it to a smaller space, which is completely included in the space spanned by the columns of the X matrix. And this can be put in a picture, and this is a picture which we'll go over again in the next 5-minute talk. Basically, we have one large model which spans a space which we can call V, and we can call this V, and we want to know whether we can reduce the space and instead project onto a smaller space. So that's the task of this entire collection of videos that are registered under the numbering scheme 545.3. So 3 refers to the group of videos that have to do with tests in the linear models. And those tests will also include the tests for estimable functions. But enough on this introduction.